Hello everybody, this is Math with Josh. I'm Joshua Phillips. Wherever you're seeing this, you can get in touch with me. And if you like the channel, please share. Just trying to spread some math education to the world. Okay, so this video is titled, Why Does the Normal Multiplication Method Work? Hopefully there'll be a part 2 where I talk about, say, the lattice approach or the so-called Common Core approach. Our starting point is to remember that what multiplication captures, for the purposes of this video, people with PhDs in math realize I'm greatly oversimplifying here, is that the problem 5 times 6 means 6 plus 6 plus 6 plus 6 plus 6, or 6 added together a total of 5 times. And you might think about it slightly differently, but this is 12 plus 6, which is 24 plus 6, which is 30. But the basic idea is that multiplication is iterated addition in this context. And, in principle, for one, you should memorize all your small times tables. You can check a previous video of mine. It's called Sharpen the Arithmetic Axe, on why I think that is valuable. But you can, in principle, do any multiplication problem by adding them together this way. So if we imagine this bigger problem of, I actually wrote this backwards, by the way, of the way I wanted to do it. Really, we're going to do, oh, I see, never mind, we are good. Okay, I fixed it in between takes, everybody. Okay, and if we had 34 by 21, we could do this as 21 plus 21 plus 21 plus 21, right, for a total of 34 21s. We could then try to add those all together very methodically, right? It's going to be, if there's this weird step, right? That'd be, 17 42s, and point being, it's going to get extremely messy. So, people wanted a method that does the problems a lot easier. And the method, which you hopefully remember, is if we wanted to do 34 times 21, we say, okay, 1 times 4 is 4, 1 times 3 is 3, 2, we go down to the next line, we put a 0 in, because we're one line down, 2 times 4 is 8, and 2 times 3 is 6. We add these together, we get 4, 11, carry the 1, 714. Okay. So that's the method. Now, the big question is, why does that method work? Let me erase that a little bit here. Might have to pause your video or go back a minute. Look at it. Because it does work, it spits out correct answers. But what we want to know is, why does it work? And to sketch out the idea, let's look at 12 times 3. So 12 times 3 is 3 plus 3. And notice I'm drawing dots here. You can imagine this as, what's a funny one? If you have 12 rows of seats of 3 people each, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7. And you want to know how many total people this is. Or you've got 3 lines of customers with 12 people in each of the lines. How long are you going to be ringing up orders today? So 3 by 12. Sorry, my grid's not very good. A very important principle is that we can actually, let me get the red color here. Nice red color. Well, 12 times 3 is very similar to just counting all these dots. But we can count the dots in whatever order we'd like. And what we were really looking for is a good way to count them quickly. Ooh, wrong line. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So the neat little trick, let's say we just draw a line here. We can count the dots as the top half of the dots, and then, the top section of the dots, and then the bottom section. Well, if we go backwards, this bottom section is 2 times 3, because it's 2 rows of 3 dots. And this top section is 12 minus 2, so 10 times 3. And so 12, we gather from this, don't think of this as exactly a proof. It is an explanation, but what we notice from this, and the general principle, is that 12 times 3 is equal to 2 times 3 plus 10 times 3. Ooh, we use stars instead of dots in these problems. Okay. And in general, this is a little bit of a jump, but this is the general idea. If we want to know, we can do a similar thing. So with 34 times 21, I'm going to use stars instead of x's for multiplication. The symbols mean the same thing. I need it to look a little more readable for you. So 34 times 21, we can actually break that up in a similar way. Now in this case, I'm going to break this up into 34 times 20 plus 34 times 1. Now if you notice to the problem we just did, this is sort of like I'm drawing a vertical line instead of a horizontal line. The principle is important, which is a multiplication problem can be rewritten in this way, where you break the times of either number. You pick a number, you keep that number the same. You can break the other number down and add the pieces together like this. Then if we go to look well, okay, so switching to the pen. So 34 times 1 is obviously 34. That piece was nice. 34 times 20, now the rule you hopefully learn is that when you multiply by a number with zeros on the end, you can just copy the zeros down, then ignore them. So we have 34 times 2 is 68. And we get 680 plus 34. And if we add those, we will get 714. The same as our answer before. Now, maybe you've noticed the trick. Let's look at one more time. Remember that the answer we got was 714. Let's look at that method we normally do for solving multiplication. So if we had 34 times 21, this first line we write is 1 times 4 is 4. 1 times 3 is 3. Notice this line is 34 times 1. This captures that we split off the 1. Now for the second step, secretly what's going on is we're not multiplying 34 by 2, we're multiplying it by 20 because the 2 is in the tens place. So first we put a 0 in, and then we do 2 times 34 is 68. Notice this is 20. Oh, I see what I did there. Sorry. 34 times 1. And this is 34 times 20. And when we add them, we're going to get 714. The correct answer. So that's the reason the multiplication method that you learned works, is that it's a simple, efficient way to do the same thing as breaking the problem down into, okay, what's the top number times the ones place of the second number plus the top number times the tens place of the second number plus the top number times the hundreds place if there was a hundreds place, etc. So I think, yeah, this video is running about 10 minutes. There'll be a further video. If I get any feedback on anything you think wasn't clear, or if anyone wants to see where like the how numbers carrying is okay and plays into how this works, please leave feedback. I'll talk about that in the next part. The next part we'll try to cover lattice multiplication or viewer questions, depending on what I get. Once again, this is Math with Josh. I'm Joshua Phillips. Please share if you enjoy the content, and have a nice day.